The last concept or skill that we're going to learn in step 3 is combining like terms. Couple of rules, they're very important. You can only combine terms that have the exact same variables, which are the letters, and exponents, which are those small little numbers in the upper part of the term here. We combine by adding or subtracting the numbers in front of the like terms and leaving the variables and exponents alone. So these words in purple might not make a lot of sense right off the bat, but as we look at some examples, when you go back and read these two very important purple statements rather, it'll make a lot more sense. The way I explain like terms to my students is instead of saying x squared or x or y or b, I give them names of actual objects. Instead of x, I say x-ray. Instead of x squared, I say Xbox because it has two x's in it. Whenever I have just a constant, I usually make that money because everybody understands working with money pretty well because we all like money. So for the first example here, I would read it, instead of reading negative 5x squared plus 5x, subtract 2x squared, subtract 8x, add 11, take away x, take away 15, as it's written, I would say give away 5 Xboxes, find 5 X-rays, give away 2 more Xboxes, give away 8 X-rays, find $11, give away an X-ray, give away $15. Because then you can picture in your mind this pile of dollars and X-rays and Xboxes, and it's easier to see which things go together. Because sometimes when you see a 5x and a 2x squared, or excuse me, a 5x and a negative 2x squared, they look similar because they both have an x. But they are not like because this one has an exponent of 2 and this one does not have an exponent of 2. It has an exponent of 1. I again encourage you to use color. Highlight all the terms that are Xboxes or X squared. Highlight all the terms that are X-rays or X terms. And finally, highlight all the terms that are constants, the money terms. From there, we're just putting them together. Give away 5, give away 2 is the same as giving away 7. Negative 5 take away 2 is the same as negative 7. If you have 5 X-rays and you give away 8 and then 1 more, you've given away 4 that you didn't have in the first place. And finally, if you have $11 and you want to spend 15, you're going to be negative 4 in the hole. You're going to need to find $4 to borrow. But the 11 and the 15, the 11 and the negative 15 go together because they don't have any variables. They're constant, which makes them like. Let's practice. If I have 2 X-rays and 3 X-rays, they're like, so I'm going to keep them the same color, but I'm leaving a little space here so that you see I have 2 separate terms. 2x plus 3x gives me 5x. Notice I didn't change the variable. I didn't make it 5x squared or something like that. I just added them. And it makes more sense if I say you have 2 X-rays and 3 X-rays. How many X-rays do you have altogether? 5 X-rays. So 2x plus 3x gives you 5x. How about over here? I'm starting off highlighting 5x. I get to a plus sign, so I stop. The next term is positive 6. That doesn't have an x, so I'm going to use a different color. and then I stop because I got to a subtraction sign. Negative 7x. Well, that's an X-ray, just like the 5 X-rays that I already made yellow. So I'm going to highlight them yellow. And again, we're just combining terms on this side of the equation. We're not going to worry about moving terms from one side of the equation to the other just yet. That will come in a later step. I have 2 yellow terms. I have 5 X-rays, take away 7 X-rays. How many X-rays will I have left? Negative 2 X-rays. The positive 6 just comes down because it has nothing to combine with, and the 14 is on the other side of the equation anyway. So I'm not going to worry about that right now. Let's take a look at number 2. I know I've kind of gone out of order. I went 1, then 5, but that's just how I was scrolling with my screen. All right, let's try this one. 5 X-rays and 2 yo-yos. Take away 3 X-rays, add 6 yo-yos. Well, if I put my 2 yellow terms together, 5x, take away 3x. You have 5 X-rays and you take away 3 X-rays. How many do you have left? You have 2 X-rays. 2 yo-yos and 6 yo-yos. How many yo-yos do you have altogether? You would have 8. It works with fractions too. 1/5 of an X-ray, 1/3 of an X-ray. I can add those together and get 8/15 of an X-ray. We add them just like we add numbers, just because they're fractions. Don't let it intimidate you. 1 X-ray, because remember that implied 1 comes right before the X. 4 X-rays, take away 2 X-rays. So imagine you're holding an X-ray, I hand you 4 more X-rays, and then I take away 2 of them. 1 plus 4, take away 2, gives me 3 X-rays, 3x. 1x plus 4x, take away 2x, is 3x. Let's try one more. Let's try number 8. Starting off with -5, that's a constant. Oh, my pen quit working. One moment. It's been giving me trouble today. There we go. -5 is a constant. There's no letter with it. Do you see any other terms that have no letter with it on the left side of the equation? -9. 1/7 x has an x with it. 4/7 x has an x term in it, an x variable. If I put my yellow terms together, -5, -9, same sign means combine, keep the sign, we get -14. 1/7 x plus 4/7 x gives me 5/7 x. So we've started with this original equation and we end up with a simplified equation because we were able to combine like terms. Now let's go back and read our purple statements one more time and see if they make a little bit more sense now that you've seen some examples. You can only combine terms that have the exact same variables. Remember, those are our letters. Or lack of letters if it's a constant. And exponents. We combine by adding or subtracting the numbers in front of the like terms and leaving the variables and exponents alone. That means we don't change the variable. It stays the same. If I start off with 5x and 2x, I'm going to have 7x. I'm not going to have 7x squared. That wouldn't make sense. You keep the same letter every time.